It's the middle of the week, Thursday actually, and I'm here at my house and I'm working on the solid state DC relay board that's going to go into the pinball machine to drive the slings and the pop bumpers. So this is going to be some solid state relays that are mounted on a board and then mounted in the pinball machine. You guys may remember that we did some testing about 4 months ago to try and use mechanical relays to do this, and that failed miserably. So we switched over to these solid state relays to do the job. The problem, it's not a big problem, but the control board I built was designed to plug directly into the mechanical relay board, but these larger DC solenoid or DC relays are going to have to be mounted external to the board. So I'm going to have to remove the connector from the board and install a different type of connector that I can plug in to the relay board. So that's what I'm working on today. Let me flip over and I'll kind of show you what I've got going so far, and then I'll show you a little bit of the design on the computer so you can see what's going on. Okay, I have this balanced on my keyboard tray, which I'm holding at exactly the right angle with my knee, which is propped up against my chair. So hopefully all of that will hold in place while I show you guys what's going on. So if you look right over here where it says X7, there's a connector you can kind of see. Let me see if I can move the camera in a little closer. You can see that I have a connector soldered in on the bottom side of the board, just like I do in all of these other connectors that are plugged into the boards underneath it. So what I'm going to have to do today is remove this connector and solder a connector on the top of the board that I can then take over to the relay board. So let me show you the relay board so you can see what I'm doing there. So here's the relay board. You can see I've labeled them Pop Bumper 1, Pop Bumper 2, Pop Bumper 3, Slingshot 1, and Slingshot 2. And I have the DC control wires. My knee didn't work. Let me set that back up again. So here are the control wires, and I'm going to trim these to length, put a connector on them, mount a mating connector on here, and then these will plug into there and that'll control these. Then the outputs of this, the positive side will be hooked up to the DC 70 volt supply, and each output will go to another connector that will take those signals to the play field and to the particular relays whenever the computer turns it on. I don't have a stand for my phone, so I do everything handheld, and that's one of the reasons why I'm not going to be filming while I'm desoldering this connector, because I'm definitely going to need my mouth, both hands, and maybe a couple of toes to get this all done correctly. But there is something I did want to point out. So here is X7, the connector that I'm going to remove, and I'll show you on the other side how it's a connector, and I have the 4 of them. Now, when I remove these, I do not try to salvage the connector. I basically destructively remove that plastic. I use a pair of nips like this to grab a hold of it and rip the plastic off, and then I take my soldering pencil and one by one I remove the leads. It's so much easier that way. And then I just put some flux on and clean it up with some solder wick, and it never messes up the board. It always works great. So So I'm going to do that, but I am not going to film it, and I'll bring you back and show you the cleaned up connector. I thought I'd bring you back and just show you this. That connector actually slides right off. It was very easy. I didn't have to cut it or break it or anything. And there's each of those pins. Technically, if I'm careful, I can remove these pins, slide them back into the connector, and maintain the connector. I'm probably not going to, but I could if I wanted to. So there you go. The connector's all cleaned up. I basically pulled the black plastic off, heated up each of the pins, pulled them out, added a little solder onto it, and then used the solder wick to suck the solder off. Cleaned up the flux with denatured alcohol, and it is ready to mount a connector on. Now I'm going to kind of make a homebrew connector here. I'm going to take these JST style connectors, which we have in multiple sizes in males and females, and I'm going to take the female connector and mount it here. I'm going to just crimp a pin on each one, and then I'm going to stick that in there and solder it on, and then I'll put the males on. I could just use a header like this because these are 0.1 inch spacing, but that doesn't allow it to latch on. So I really want the latching ability. So I'll show you how that's going after I get the connector put together. So I hope you can see this, but I'm pulling pins out of this header, taking these connectors off the connector strip, using my crimping tool to crimp them together and make a pin like this. So now I'm going to take, focus, I'm going to take that pin and I'm going to insert it into that shell so that the pin sticks out the bottom, and then when I have all 9 of them done, I'm going to solder them into the board. Okay, you can see from this schematic how the DC relays will drive the pop bumpers and the slings in our design. So over on the right here, 70 volt DC comes into each of the relays. Now I'm not showing the control wires in this particular drawing. I'm just showing the solenoid wiring. So, but you can see that here are the DC relays. They are controlled by X7. I pointed to connector X7 a little bit ago. Bit 0, 1, 2, actually this is port B0, B1, B2, B3, and B4. And those drive pop bumper 1, 2, 3, and the left sling and the right sling, which I think I called sling 1 and sling 2 on my tags. And then the ground wire just returns. So this connector P3 will be put on the wires that are coming from the play field, and this connector I will install today and wire it up to these solenoids. Now I just got through putting another schematic together that shows all of the wiring and how it's going to connect. Here is that same J3 that was in the other drawing. Ground wire on the bottom, the lines coming from the solenoids going to each of the relays, and then the plus 70 volts coming in from terminal block 3, which will be on the 70 volt DC power supply board, which I also still need to build. And then there's going to be a control wire coming in from X7, port B0, 1, 2, 3, and 4. And there's a common ground that feeds those. So what isn't shown here is that I'm going to have to install a connector right here to allow me to connect this to the board. Technically, I could solder this together since they are all on, so they're all in the back box and they don't have to be moved, but we want to make it a little more modular than that. So there's going to be a connector installed here that will connect this up. Now, going back up to the back box, this is a not to scale representation of the back box. So you got the 4 score wheels, you got the credit counter in the middle, and I showed you guys last Monday this control board mounted in here. Over on the other side of the score wheel, the DC relay board that I just showed you is going to be mounted, and right in the middle is going to be the DC power supply and the terminal blocks for distributing both the AC and DC power back to the units back here. We aren't using terminal strips for the 5 volts, I don't think. I'll have to recheck that, but they will not be going on this board even if we are using them. This is just going to be the 50 volts AC and the 70 volts DC. So that's it. I could show you one other thing that we haven't shown yet, and that's how the wiring is going to be done in the base of the unit. So AC power is going to come in the back. There's a slot in the back where the AC power cord comes in. And we're going to mount a little distribution box with a couple of utility outlets right there. So if we need light or power or something in the box, we've got something to plug it into. And then the hot line is going to run down to the switch. It's going to come out of the switch, go to an 8 amp fuse. That 8 amp fuse is going to run over and power the original 50 volt AC transformer, and it's also going to power the 5 volt DC power supply that's going to be used for driving the computer board and the LEDs. The neutral wire is going to come out and be connected to there also, and then each of those outputs, the 50 volt AC is going to have a 10 amp fuse on it. That line actually drives all of the AC solenoids and the DC 70 volt power supply, so it takes a bit of current. The 5 volt power supply is, I believe, a 6 amp supply. We're going to fuse it at 5 amps, and that should be more than adequate to drive the computer and all of the LEDs. So that's it for now. When I get the connector put together, I'll bring you back and show you what that looks like. I'm not going to take you through the step-by-step crimping of the wires. That's really dull, and hundreds of people have done that already, so there's no reason to actually show you doing that. But I'll show you what it looks like when it's all put back together. Thanks a lot. Okay, I've finished wiring up the DC relay board. As you can see, I've got the output wires up here at the top all connected to J3 here. The mating connector of that will be hooked onto the wires coming from the play field, and that would be the wires coming from the pop bumpers and the slingshots, plus their green ground wire coming up here, and that'll connect into there. Now down on the bottom here are the signal wires, and they run over and into the new connector that I installed on the control board. So basically the blue wire there is the ground wire, and then there's 5 signal wires to activate the 5 relays. I'll probably punch in a little bit of test code just to cycle through and activate each of those solenoids. I don't have a load to put on it, but it lights a light to show that it's activating the solenoids, and I'll go ahead and try that, and I'll show you guys that when I'm done. And then lastly, there's a couple of wires here that go to terminal blocks 3 and 4, and that's the 70 volt DC power supply that I have yet to build. That board will basically sit about right here in the box, and it's going to have a full wave bridge rectifier, capacitor, fuse, and 4 terminal blocks, the 50-volt AC coming in and the 70-volt DC going out. So I'll probably build that later on today. I think right now I'm going to go ahead and try to load in some code and see if I can activate these just to make sure I've got it all wired right. So I'll bring you back and show you that when I get it going. So I said I was going to write a little code to test out the relays, but I realized that I really didn't have to do that because I've already been developing the code for the actual game, and I could just modify that a little bit to make this work. So let me first show you the inputs. This is a 3D representation of the board, and these 4 port expanders are used to input all of the switch inputs. And X2, expander 2, is used to input the switches for the pop bumpers and slingshots. So all I need to do is ground out the appropriate pins on this connector, and my code should see that the switch is made for that component and fire off the appropriate relay. Now the relay drivers are handled by X0, X1, X6, and X7, and specifically the B ports of those. So X1B, X6B, X0B, and X7B are driving the relays that drive the solenoids. And for us, we are using X7. So to show you my code, I have a switch processing routine that gets activated every 25 milliseconds, checks to see if any switch changes have occurred. If they have, it processes that particular switch change. By the way, this code isn't even anywhere near beta yet. It's got lots of bugs in it. It's a work in progress, but it works fine for this part of what I wanted to test. So I've added this line just declaring a boolean called test solenoids equals true, and then in the X2 processing I added in the line where I say if solenoids are allowed, or if test solenoids, then go ahead and run this code. So I'm only doing this for the X2 inputs, and there's 16 of those. I'm only going to be testing 5. So I first read in the value from the switches. I check to see if there has been a change. Let me step up a little bit here. I read in the value from the switches from extender 2, and this is a read A-B, so it, even though I'm reading from GPIO-A, it reads both GPIO-A and B as a 16-bit variable into the variable switches. And then I take the current value of switches, I exclusively OR it with the previous value of switches, and if anything has changed, this exclusive OR will result in the changed bits being set to a 1. So then I just check and see if changes are not equal to 0, then I have to process some changes. Otherwise I don't. 99% of the time when coming through these loops, you will look, there won't be any change, and you'll just jump over all this code. So this loop will only really process 4 reads and check the changes, and then it'll reset the timer and jump out. But if there was a change and the solenoids are being allowed, which means gameplay is in progress, or in this case, test is in progress. Then I check to see if change N1, so I'm checking to see if the first bit is set, and if it is, that's the pop bumper switch, and I put a little debug statement saying pop bump has changed, and then if it's a 1, I turn the pop bumper on, and then I leave. The next time through I check, and if it's changed again, then it has changed from on to off, and I come through here and I say, is the switch a 1? No, so it has changed, but it's not a 1, so I drop through and I turn the relay back off. And I do that for pop bumper 1, pop bumper 2, pop bumper 3, and also for the left sling and right sling. Now, there's a little bit of difference in the code here because the pop bumpers cause a scoring, and this little set of code just adds 1 or 10 to the score, depending on whether the even or odd toggle is set. So, but we're not going to do any scoring right now. We're just turning on relays. I'll bring my debug window over here, and I'll go ahead and connect pop bumper 1 and touch it to ground, and you see pop bumper 1 is on, and when I let it go, pop bumper 1 is off. You can't see, but the relay is lighting. I'll pop back here in just a second and catch a little bit of film of that so you can see that. And so that is working really well. I don't have debug statements in all the rest of the code, all the rest of them. It just simply says that a change occurred. It says pop bumper 2 changed, but I don't have the on and off in there. And here's pop bumper 3. Pop bumper 3 changed. And then here's slingshot 1. Okay. That should say SL, not LS, but it's okay. It's just a debug statement. And there's LS2. Going back, I'm gonna grab my camera really quick and see if I can show you the real or the pop bumpers. And over here, I have my X2 input, and right over here is a little ground. So I'm gonna point on here, and I touch the ground, and you can see pop bumper 1 light when I have it down and turn off when I have it up. And then if I move to pop bumper 2, push it down, pop bumper 2 lights, up, goes off. Pop bumper 3, down is on, up is off. Slingshot, down is on, and slingshot 2, down is on, up. So all of those wiring seems to be correct. Actually, I did have a wiring problem. When I put my connector together, I actually missed by 1 hole. I should have had it starting in this end hole right here. It's not focusing because I'm too close. Anyway, I didn't, so I just relabeled my schematic, and that fixed that. So anyway, I think this is going to end this video. I'm still going to build the board that goes here that has the DC power supply on it. I probably won't film that. I'll just show that to you guys on Monday when we install it. So this will end it. Thanks for watching. Really enjoyed this, and as you can see, the changes and stuff are still popping up there. So that is it. Thanks a lot. Bye-bye.